Good evening, Mananda. Welcome to the lecture series of signal systems. This is Dr. P. Srinivaswamy, Associate Professor, Ashantra College of Engineering Technology, Budur. Today, we are going to discuss about Fourier transform of cos omega naught t, sin omega naught t, and its spectrum. How to draw the spectrum of cos omega naught t, sin omega naught t. Now, you consider the signal x of t. X of t is equal to cos omega naught t. This cos function, you can, instead of applying Fourier transform directly, you can express this cos function in terms of exponentials. So we know cos omega naught t is equal to e power j omega naught t plus e power minus j omega naught t by 2. And then if we apply Fourier transform on both sides, x of t Fourier transform is x of omega. Now Fourier transform of e power j omega naught t, we are going to calculate from Fourier transform properties. From the Fourier transform property, I am going to use here a frequency shifting property. Now it is an x of t. This x of t is multiplied with e power j beta t. Now Fourier transform of this e power j beta x of t is x of omega minus beta. So this concept I am applying here. This e power j omega naught t like e power j beta t. Here omega naught is equal to beta. In this x of t, I have considered a 1. So there is no any change if we multiply e power j omega naught t with 1. So you know 1 means a DC signal. It is a standard signal. Fourier transform of 1 already we discussed in previous class. Fourier transform of 1 is 2 pi into delta of omega. That is Fourier transform of DC signal is 2 pi into delta of omega. So according to the frequency shifting property, now half into e power j omega naught t or e power j omega naught t into 1 is 2 pi into delta omega minus omega naught, because x of t is a DC signal. This spectrum or Fourier transform of this DC signal is 2 pi into delta of omega. Because of this frequency shifting property, because of this exponential term, this omega is delayed by beta times. Here beta, instead of beta, we have omega naught. So there is already 1 by 2. So 1 by 2 gets cancelled. You will get pi into delta of omega minus omega. It is a delayed version of impulse in frequency domain. Now, similarly, if you want to calculate this e power minus j omega naught t, instead of delayed version of the delta function in frequency domain, it is going to be get a advanced version of delta function. That is a delta of omega plus omega naught. Now, overall signal for a transform of this cos omega naught t, we are going to get pi into delta of omega minus omega naught plus pi into delta of omega plus omega naught. Now, if you want to draw this magnitude spectrum, this entire magnitude spectrum of this cos omega naught t, we are going to present the frequency components only at 2 frequencies. One is at omega equal to omega naught. Another one is at omega equal to minus omega naught, because delta function is existing only at omega equal to omega naught, omega at omega equal to minus omega naught, and their corresponding amplitudes at whenever there is a omega equal to omega naught, if there is an impulse and corresponding amplitude is pi. Similarly, this delta of omega plus omega naught it is exist at omega equal to minus omega naught, and its corresponding amplitude is pi. It is about magnitude spectrum. Similarly, if you want to calculate this sine omega naught, in a similar fashion, we know sine omega naught t, if you want to express in exponential functions, e power j omega naught t minus e power minus j omega naught t by 2j. Now, this 2j you write separate. You can already in the previous derivation also, we have seen Fourier transform of e power j omega naught t into 1 according to frequency shifting property 2 pi into delta of omega minus omega naught. E power minus j omega naught t Fourier transform is 2 pi into delta of omega plus omega naught. So similar fashion, we are going to get only change is there is only a pi. Now here it is a pi by j. Now if you want to draw this spectrum at omega equal to omega naught, you will get at omega equal to omega naught. If you want to draw this magnitude spectrum, if you want to draw the magnitude spectrum, this j, if you multiply numerator, denominator, so in the numerator we are going to get pi j, in the denominator we are going to get j square, it is a minus 1. So minus j pi, so root of, whenever if you want to calculate magnitude, root of real square plus imaginary square. So anyway here real part is 0, imaginary part is minus pi. So minus pi whole square, pi square, root of pi, root of root square get cancelled. We are going to get pi. Similarly, at omega equal to minus omega naught, you will get minus pi. So it is the magnitude spectrum of sine omega naught. Okay. Now, if we see another problem, find the convolution time for a transform of the following signal. Suppose if you want to find the continuous time for a transform of the following signals. Another signals also has given cos omega naught t u of t. Another signal is sin omega naught t u of t. Now, this cos omega naught t u of t, usually, you know, if you apply Fourier transform x of t, that is x of omega, is equal to integral minus infinity to infinity x of t into e power minus j omega t into dt. Now, you know this about this step function, unit step function. This u of t is 1 for time t greater than or equal to 0, and it is 0 otherwise. So, we can change these limits from minus infinity to plus infinity to 0 to infinity. Within these limits, this u of t is 1 cos omega naught t into e power minus j omega t into dt. Now, whatever we have, this cos omega naught t, again, you can write like e power j omega naught t plus e power minus j omega naught t by 2. So, this already we have a e power minus j omega t. You multiply this e power minus j omega t, these two terms. So, you will get e power minus j omega minus omega naught t plus e power minus j omega plus omega naught t. Now, if we integrate this exponential function with respect to time, and then if you substitute these limits, so we are going to get this Fourier transform of cos omega naught t u of t 2 omega by j into omega square minus omega naught square. It is directly we can calculate. Otherwise, we can also calculate this one by using the time domain multiplication in time. Multiplication in time is nothing but convolution in frequency. So already we know this cos omega naught t, and you know this Fourier transform of u of t. So convolution in frequency property, based on this convolution frequency property also, we can calculate this Fourier transform of cos omega naught t into u of t. So we will see the next class. We'll continue the next class. I'm going to stop.